Excuse me. So let's continue to find exact values. Let's make sure we get everything in sight here. So we're going to continue to find exact values, but these questions are a little bit more abstract. So we have to kind of think about what information we're given before we can determine the exact values, in this case of cosine, secant, and cotangent. So, okay, so what we're given in this point, at this part, is a point on the terminal side of theta. All right, so let's think about what this means. I'm going to draw my angle just like we did before. All right, so think about it. This point is, so the square root of 11 is positive and negative 5 is negative. So to plot a point that has a positive x coordinate and a negative y coordinate, that would place that point in quadrant 4. Okay, so again, we went to the right and down. Okay, so that means if this point is on the terminal side of my angle, we're looking at something like this. Okay, so the reference angle would be right here. And if I'm going to draw a triangle to help me, I'm going to drop the altitude this way, because remember, we have to use the reference angle that is always made with the terminal side of the angle and the x-axis. So now let's think about what we know. So the square root of 11, again, that was the amount, right? That's the distance that we went this way. So that would be the square root of 11. And then from there, we went down negative 5 to get to that point. So this would be negative 5. This is a right triangle. So to find the hypotenuse, I'm just going to call it x. I can use the Pythagorean theorem. So once we have all three sides of the triangle, then we can find exact values of whatever angle that is. Any of the trig ratios of any, whatever that angle is. So let's remember, when I'm using Pythagorean theorem, it's a squared plus b squared equals c squared. And the a squared and the b squared have to be the legs of the triangle. The c squared is the hypotenuse opposite the right angle. So we'll say, okay, the square root of 11 squared plus negative 5 squared is equal to c squared. So this is 11 plus 25 is equal to c squared. So c squared, or actually, we're actually calling that x. I guess we could just call it c, is 36. So the square root of c squared is c, so the square root of 36 is 6. So that tells me that this side of the triangle is 6. Okay, so now if we're thinking about this is our theta, I have to think about what's positive where, right? So we're going to find an exact value for cosine, for secant, and for cotangent. And I'm going to think about the sign, meaning whether that value is going to be positive or negative, before I do anything else. So what I keep in mind, again, is C-A-S-T. So the C down here implies that the only functions that would have a positive value are cosine and its reciprocal, secant. Okay, so my cosine value will be positive, my secant value will be positive, but my cotangent value will be negative when I apply the ratios of this right triangle. Okay, so remember, cosine, when I'm looking at the right triangle, is adjacent over hypotenuse. Secant is the reciprocal of that, so hypotenuse over the adjacent side. And cotangent is adjacent over opposite. So remember that SOHCAHTOA, what we think sometimes, and that helps us with sine, cosine, and tangent, and then those reciprocal functions, of course, are the opposite. Okay, so going back to cosine, so here's my theta, so adjacent will be a square root of 11 over the hypotenuse, which is 6. So for secant theta, secant theta is going to be the opposite. So really it's the reciprocal of this. So 6 over the square root of 11. Alex will probably want you to rationalize that. So we would multiply top and bottom by the square root of 11, which gives us 6 square root 11 over 11. And then cotangent, so that's adjacent over opposite. So that would be the square root of 11 over 5. And again, you can think of this as being a -5. You can think of this as being a +5, as long as you're considering what functions are positive and what functions are negative according to the quadrant that you're in. So I determined that was going to be negative right off the bat. So I was really treating this more as just a side length of 5. Okay, let's take a look at our next example. So now we have theta can be an angle in quadrant 1 such that sine theta is 5 over 13. Okay, so let's go ahead and plot that. So here's quadrant 1. So I'm just going to draw an angle. Remember, I always want to consider the angle made with the x-axis. So that's how I'll draw my triangle. And sine, I know, is opposite over hypotenuse. So this would be 5 over 13. So to find the other side, again, whatever we want to call it, since it's one of the legs, I'll just call it A. We can use the Pythagorean theorem. And then remember that everything's positive in quadrant 1. Okay, so we would have a squared plus 5 squared is equal to 13 squared. So a squared plus 25 is equal to 169. So a squared subtracting the 25 will give me 144. And so a is equal to 12. All right, so now I have all 3 sides. So now I can find the exact values of secant theta and tangent theta. And again, we already determined that those would be positive because that theta's in quadrant 1. And remember, secant would be hypotenuse over adjacent, and tangent would be opposite over adjacent. So when I'm looking at my triangle here, secant is adjacent, which is 12, over the hypotenuse, which is 13. And tangent is opposite over adjacent, which would be 5 over 12. Okay, and our last example. So this time we have an angle theta. Whoops. Let's see if I can make that bigger again. Not sure how it got like that. There we go. Okay, so let's draw this angle according to what we know. All right, so such that sine is -5 over 13. So what I'm seeing there is that sine theta is equal to a negative number. And then with cotangent is greater than 0, that's telling me that cotangent greater than 0 would mean it's positive. So let's think about where I'm going to draw this angle. Okay, so it's not in quadrant 1 because sine is negative. It's not in quadrant 2 because sine is negative, and sine is positive in quadrant 3 or 2. So let's see, in quadrant 3, sine would be negative and cotangent would be positive. So it looks like we'll be in quadrant 3, because in quadrant 4, both sine and cotangent would be negative. So we're going to draw our angle in the 3rd quadrant. So this is actually the angle, but we're going to focus on the reference angle and draw our triangle like this. Okay, so here let me just remove my check mark so that doesn't confuse us. And now let's see what we know. So because we're told that sine, again, is negative, so I'm accounting for that by where I'm drawing the triangle. and it's opposite over hypotenuse. So opposite the reference angle would go 5, and then the hypotenuse would be 13. So again, I can find the other leg, we'll just call it A, using the Pythagorean theorem. So we can say a squared plus 5 squared is equal to 13 squared. So a squared plus 25 is equal to 169. So similar to the one that we just did, we'll have a squared is equal to 144, and again, a in this case will be 12, sorry. 169 minus 25 is 144, and the square root of 144 is 12. So a is equal to 12. Okay, so now let's answer the question. We're looking for values for tangent of theta and secant of theta. So let's think about whether they're positive or negative first. So in this quadrant, CAST, my T kind of got lost, tangent is positive, but secant is negative. So now when I look at my ratios, remember tangent is opposite over adjacent, and secant would be the hypotenuse over the adjacent side. So here's my angle. Opposite over adjacent would be 5 over 12, and adjacent over the hypotenuse over adjacent would be 13 over 12. Okay, so again, hopefully that helps. Look at some different examples where we're still finding exact values, but we're not given that specific theta.